Hello, I'm Stéphane Bégodeau, Sirius Web Architect at OBO.
And I'm Axel Richard, consultant at OBO.
So today we will show you how to integrate a graphical editor in a Cloud IDE thanks to Sirius Web. So first of all, what is Sirius Web? So with Sirius Web, you have all the power of the Sirius desktop approach, but this time in the cloud. It comes with a graphical and domain-specific tooling. Everything can be configured with a very simple configuration file. It's deployed on a web server, and this time rendered in the web browser with collaborative support. First, let me give you some context, and let's see what's inside the Sirius Web project. So the Sirius Web project contains a ready-to-use modeling framework to define and render graphical application in the web. You could embed this framework in other applications as you like. It also provides an open source model server with various components that you can reuse. With this, you can build your own Sirius Web backend for your need. And on top of that, it provides a complete open source application offering tons of features, such as diagrams, properties, forms. This allows us to integrate Sirius Web components in modern cloud IDEs. Finally, Sirius Web relies on regular web technologies like Spring Boot, Reactor, GraphQL, Apollo, React, Xstate to deliver a great user experience. It's also based on other Eclipse technologies such as Sirius, Sprotty, and EMF, among others. So with that, we also have OBO Cloud Platform, which is all the features of Sirius Web with additional collaborative and access control features, such as authentication, authorization, private projects, and role-based access control. It also comes with indicator of active users to have advanced collaborative experience. Both Sirius Web and OBO Cloud Platform are completely customizable. You can configure them with the concept from your domain, and then you can create the graphical representation that you need, your own diagrams, your own tools with a specific behavior, your custom validation rules too. Finally, you can also import existing Sirius desktop configuration quite easily. For this presentation, we will rely on a Flow Designer example that we had created for Sirius Desktop in the past. So what do we have in mind when we talk about integration in cloud IDEs? So first of all, we will integrate the IDE with our model server. We will leverage both our HTTP and WebSocket API to perform GraphQL queries against the server. We will also integrate our graphical editors, such as diagrams and forms editor inside the IDE, and we will package all that as a VS Code extension that can be also used inside of Theia. So to start integrating Sirius Web in the Cloud IDE or in any application, any web application, you'll need first the latest release of Sirius component that you can find on GitHub. It contains all the React components that are used to display diagrams and forms, for example. And you will also need an instance of the Sirius Web Server, which will provide the HTTP and WebSocket GraphQL API. All this is open source on GitHub, on the Eclipse Sirius organization. Sirius Web is a final application. It's an example of how Sirius components can be used. And Sirius components provides the core front-end and back-end components to build a modeling workbench in the web. So when you start with a Sirius Web Server, you have access to both the model server with its GraphQL API and our front-end application. So in this application, you have access to our modeling workbench with the Explorer on the left, where you will be able to see your concepts, and the detailed view on the right with the properties of the currently selected element. In the middle, you will have your editors with diagrams and forms, for example, computed from your configuration. Now, Axel will show you a demo of both Sirius Web and its integration in VS Code and Theia.
Okay, so let's go for the demo. So on the background, we have a Sirius Web server running. So on the right of the screen, you can see a web browser with Sirius Web running. So you have the Explorer part on the left, the details view, the properties view on the right, and a diagram opened in the middle. So when I change the properties of an element, it changes the element on the diagram. I can also move elements, I can create, delete elements, rename elements, and so on. So now, on the left of the screen, I have a VS Code with the Sirius Web extension installed in it. So first, I need to register to the Sirius Web server. Okay, I set name. When I click on the server, it retrieves the project. You can see the project one. If I click on the project one, I can see the same explorer than the one in the web browser. I can also see all the representation created in this model. Okay, so if I click on a representation, I see the same graphical editor than in the web browser. And it is fully collaborative. So it means if I do any change in one side, it is updated in real time on the other side. So if I move the GPU element, it's also moving on the other side. If I try to change the properties usage, then it changes the color of Motion Engine on both clients. Pretty cool, right? I can also open the properties view in VS Code and change as well the properties. Okay, so the integration in VS Code will be detailed in 4 steps. First, we will see the basic principles to create a new VS Code extension. Then we will create multiple VS Code tree views to manipulate Sirius Web servers, projects, and representations. After that, we will show a tree view for the Model Explorer, just like in Sirius Web. And finally, we will create a web view to display graphical editors, such as diagrams and properties. In VS Code, we are not in a web browser, so we can connect to a Sirius Web server from an address bar. So we have provided a dedicated tree view allowing us to register Sirius Web servers and display already registered ones. By clicking on the Register New Server item in the servers view, an input box is asking for a Sirius Web server URL. Then the name of the server is required. You can set the name you want and confirm with Enter. Your server is now registered and displayed in the servers view. Now that we have a connection with the server, we can leverage it and retrieve and display additional data. But first, we need to have a closer look to the architecture of VS Code. Indeed, since VS Code is based on Electron, it comes with both Node.js runtime and Chrome. If you write a VS Code extension, most of the features of the IDE will be manipulated from a Node.js environment. To make things easier to understand, the code running in the left is deployed in a Node.js environment, so no support for cookies, fetch API, etc. On the other hand, the code executed in a VS Code editor is running in an HTML document. It's not a regular web page since it's not really hosted anywhere. So you won't have access to all the APIs that you have in the browser, but it's much closer to a real web browser. In the end, it's not an issue. You can interact with our APIs from either a node-based or a browser-based environment. In the package.json file of the VS Code extension, we have declared a view container and some views. Here is the part declaring the server's view, for example. And that's it. With these few lines, we have a view container and our first view in VS Code. Now that we have declared our server's view, we need to populate it. For that, we register a tree data provider that will provide the content of the tree. On registered server tree items, we have bound a command allowing us to connect to the server on a click. This command will call the code you see on screen. We use the server address associated to the tree item to connect to it. And for that, we use Axios, an HTTP client, to send HTTP requests, since we are in the Node.js environment and we will only have access to low-level APIs otherwise. Then we need to store the cookie from the response, because we will reuse it in our following request to this server. We need to manipulate cookies programmatically, because we are not in a web browser here. When we click on a registered server, we want to authenticate, but also want to list all projects stored in this server. So we have used the same mechanism presented before to create a view for the projects. After a successful authentication, we retrieve the project stored in the server thanks to GraphQL. All GraphQL queries sent to the server over HTTP are using the /API/GraphQL endpoint. To support authentication, we need to provide the cookie we have retrieved before in the headers of the HTTP request. Then the GraphQL query retrieve all projects on the server with their ID, name, and visibility. You could use tools like GraphQL in order to discover tools like Graphical in order to discover all the concepts of our GraphQL API and to validate your queries. With Axios, we send the HTTP request containing the GraphQL query and then wait for the response. From the response, we create data structures called project data, containing all data retrieved in the response. The project data are then displayed in the tree view. When we click on a project tree item, we want to retrieve the representations existing in the selected project and list them in a dedicated view. So we have used the same mechanism presented before to create a view for the representations. We also use GraphQL over HTTP once again to retrieve the representations, as we have done it before for the projects. The query is just different.
So in order to display the Explorer tree view, we are not doing the same thing as for the other tree views. We will not use our GraphQL API over HTTP. This time we will use our GraphQL API, but over WebSocket. Since we want to display model element from the project, we will use the same configuration from the Explorer of the server. This configuration needs to use a GraphQL subscription. It can be parameterized. You can choose how you want your model elements to appear in the Explorer. You can add additional elements. You can change them, change how they appear. You don't have to match the exact structure of your model. For that, it's based on the tree representation server side. So we are using a GraphQL subscription to have a real-time update support inside of this tree view. So if someone manipulates your model elements in another representation, in a web browser, or in a diagram, you will receive the update in real time in this part of the IDE. We are relying on the GraphQL WS protocol for that, which is also used by tools like Apollo or Graphical. So this is how we connect to the server. We are still inside of the Node.js environment, so we don't have access to exactly the same API as inside of the web browser. First of all, we need to create the GraphQL query for the subscription. It's a regular GraphQL query, but this time to listen to events on the tree of the Explorer. Then we need to connect to the WebSocket endpoint, which is /subscriptions. We still need to provide the cookie programmatically because we are still in the Node.js environment. And then we can open the WebSocket connection. We register a couple of callbacks on some event, on error, on close, on open, and also on message. When the connection is established, we can start with a start message. This will tell the server that we want to receive update for the given subscription. After that, we will receive messages each time a new refresh event occurs. And then we will use them to update the data structure of our tree view. This is what will allow us to have collaborative support. So as you can see, we have the result here with all of our tree views, but our integration with VS Code does not stop here. It also comes with graphical editors for our representations and model elements.
So now we have listed the representation existing in our project. We want to display the graphical editor allowing you to view and edit our representation. To do it, we want to use the same React components that are used by the Sirius Web frontend. In VS Code, the concept of WebView allows us to execute both HTML and JavaScript code inside the editor. When we click on a representation tree item, we want to open a graphical editor in a WebView. After declaring the command in the package JSON file, we need to register the command in the extension TS file. The command is also bound to the representation tree item. The VS Code WebView will execute a part of the code of our extension located in a separate script named Sirius Web.js. To create the WebView, we will first build its DOM as a string with a reference to this script. This script is a regular React application using Sirius components, which will be displayed inside of the VS Code editor. We can use this opportunity to send data from the Node.js process to the WebView by using the window object. Sirius component uses Apollo client to handle HTTP requests and WebSocket connections to the server. Contrary to the Node.js environment, we don't have to create everything from scratch. We just need to configure the Apollo client, no need for Axios or the raw WebSocket connection. You can see now the configuration of the HTTP and WebSocket endpoints for Apollo client. Here we are configuring Apollo to use a WebSocket connection for subscriptions and the HTTP connection for everything else. After that, the WebView just needs to call its core component named app. Inside of this component, we will have most of the logic of the editor using Sirius components. But first, we need to tell Sirius components where it can find the server using the server context component and to register the Apollo client configuration. Our app component will use the React component named diagram WebSocket container from Sirius components to manipulate diagrams. If the WebView is called from a model element from the Explorer view, then the properties WebSocket container component is called instead. This React component handles the display and edition of the properties of a model element. In the WebView, we are not in a real web browser, so we can't manipulate cookies programmatically to support OBO Cloud Platform. Thus, we cannot leverage the cookie retrieve from our first connection to the server in the Node.js environment. So we need to perform the authentication once again, but this time we can use the regular fetch API of the web environment, and the cookies will be saved almost like in a real web browser.
So since we are in a Chrome-based WebView, we can now access the Chrome DevTools to inspect the behavior of our extension. Here, we can see our editor performing the authentication and retrieving the cookies used for additional requests. The communication with the server is working as expected from the React application within VS Code. In order to display this diagram, the diagram WebSocket container will perform two different actions. First, it will retrieve the tools over HTTP. While waiting for the response, it will also subscribe to diagram refresh events over the WebSocket connection. Here, you can see our GraphQL request to retrieve the tools of the diagram. With GraphQL, you can ask precisely for a specific set of data, and you will retrieve exactly what you have asked for. And here, you can see the response from the server with the description of the tools needed for the diagram editor. After that, we are using the WebSocket endpoint /subscription to subscribe to diagram refresh events. So here we begin by sending a start message indicating that we want to subscribe to diagram events for a specific diagrams. And after that, we will receive diagram refreshed events with the structure of the whole diagram, all the nodes, all the edges. This will also allow collaborative support for the diagrams. For the properties editor, it's the same thing. You can use the same WebSocket connection as for the diagrams, and this time you can listen for form refreshed events. This will also allow you to work collaboratively on diagrams, just like on forms, just like with diagrams, without any issues.
So our VS Code extension can also run in Eclipse Theia, since this Cloud IDE supports VS Code extensions. The result is pretty much the same done in VS Code, as you can see on screen, as VS Code and Theia looks quite similar, but this time it runs in a web browser. All we did was to package our VS Code extension as a VSIX file and put it in the extension folder of our Theia instance. We did not run into any compatibility issue, just a couple of very minor APIs not supported by Theia. So let's go for a short demo of the integration in Eclipse Theia. So I have Theia running in background, and here in my web browser, you can see the Theia running. So as I told you, it looks quite similar to the VS Code extension. So I need to register to the server, and then I can retrieve my projects. And when I click on, let's say, project 1, I get the content of the project and the representation associated. And as in the Sirius Web frontend in the web browser, it is also fully collaborative. So if I try to move an element from one side, it also moves on the other side. I can create elements. I can delete elements. Okay. I can also open properties view, properties editor. I can change any properties in this properties editor. Okay, so thank you for attending this presentation. If you want to try it, you can download Sirius Web from GitHub. You can then customize it with your concepts and your diagrams to have your own modeling workbench. You can also use our hosted version of Bio Cloud Platform, which comes with additional features. So thanks again for attending, and if you have any question, do not hesitate.
So the first question is the VS Code extension open source? It will be open source. It will be available on the Eclipse Sirius GitHub organization, maybe this week or next week. So yes. The second question, is it possible to associate a file from classical VS Code 3 view to a diagram editor? For example, could I double click on my file and depending on the file extension, it would open the Sirius Web-based diagram editor? Yes, it would be possible for us to add this feature to let you use existing files from your file system with the Sirius Web server. So since the project and representation views are not using the subscription API, does it mean they don't get updated if project and representation are created, deleted in Sirius Web outside of VS Code?
Yes, you're absolutely right. In the future, we probably have to add refresh buttons on these VS Code views, or develop a subscription for this part too.
Does it mean that if I install the VS Code extension, I could use it for any metamodel representation I created with Sirius Web?
Yes, we have developed this extension to be able to work with any metamodel and representation created with Sirius Web.
How do you recommend to implement advanced custom services with elements from the Sirius model server, equivalent to Java services in the Sirius desktop, which can be invoked in SQL expression? Should we implement them in TypeScript in the backend so that ODesign can read them? So yes, you would need to contribute them on the backend, but the backend is in Java, so you would need to implement them in Java, not in TypeScript. So you can reuse existing Java services that you have created for your Sirius desktop workbench if you need to. Is there a predefined way to deploy Theia with Sirius Web in a cloud context, or do you have any recommendation?
No, we don't have.
You need to have the Sirius Web server, I think, close to where you have deployed the Theia backend to have a low latency between the two servers. But apart from that, I don't think you need anything specific.
Does collaboration means I can have a server side undo stack that gets served by multiple users at the same time? So 3 people working at the same time at one diagram and see what each other is doing.
Yes, if you have 3 users, one on VS Code, the other one on Theia, and the last one on the Chrome web browser, and if one of them changes something on the diagram, the other 2 will see the update in real time. Yeah, you don't have to refresh the page, you don't have to do anything. All operations on the workbench are visible in real time by other users.
And yes, that's the power of Sirius Web. It's fully collaborative and in real time.
Do you use Theia extension or Theia plugin? Right now, we only have a VS Code extension, and it works just like that on Theia. We did not have to create anything specific on the Theia side for the moment. Is it possible to track metamodels and models created in Sirius Web on a traditional version control system like Git? We have some, I would say it's not possible as is, but you could extend Sirius Web because it's made to be modified for your need and for a specific project. So you could modify it to listen to changes in the models, to send them to a remote service or to store them on the file system. If you want to, that would be quite easy to do. For the meta models, it could also be done, but in both for both concerns, you would have to modify the way Sirius Web works in order to register custom listeners at some location to have those events. Is it possible to run this without a server or local server in case of a desktop application? You could run this with a local server. In the demo, we have a server running locally, and we connect to the localhost URL.
Thank you.
Thank you for the question.
Thank you for attending. Bye.
Bye.